All right, guys, we're going to be working with the intermediate value theorem today. And the intermediate value theorem is essentially what it says it is. It means that if we have values, I want you guys to think about a function. I'm just going to give you kind of a general idea. If we have a continuous function, so first off, we have to have that the function is continuous. That is key. Continuous is key. Continuous is key. This has to be true. All we're saying is that if we have a value, so let's say when I plug in, pretend this is a 4, and then we'll pretend there's an 8 over here. I know that that's not to scale, but just bear with me. If I plug in a 4 and my output was 2, and I plug in an 8 and my output is 10, that means that there has to be an input somewhere between 4 and 8 that gives me an output somewhere between 2 and 10. So essentially all we're doing when we're using the intermediate value theorem is we're saying that there is a value that is intermediate, right? Intermediate means inter or in between. Mediate is the middle. So it's in the middle of the two given functions. So it says we have a continuous function. Remember, continuous is key. F defined on a closed interval AB. So let's say that this is function f. I'm just going to draw whatever I want here. We'll call this as function f. It's closed on an interval AB. So let's actually rewrite this and close it on an interval. Here's my closed interval. It's inclusive because it's a bracket notation. So here's point A, here's point B, for which 0 is between f of A and f of B. So we're saying there exists a point between f and b such that, so we're saying that 0 is a point or an output that is somewhere between, let's just say it's right here. We're saying that there is a point where the output is 0. So what does that mean that it has to be? So we know that there is a output of 0 somewhere between f and b. So what that means is we have to plug in some number. So here's f of a. Whoops, that would just be a. The output would be f of a. So if we have a here, this output would be f of a. This output would be f of b. So we're saying that there exists some value such that this output is 0. So something equals 0. So I'm going to say here that f of c, so we'll call this like point C lies here. And when I input a c, that's going to give me an output of 0. So now let's take this, that was more theoretical, and let's do some specific values. This next question says, use the intermediate value theorem to show that the function f of x equals x times e to the x minus 1, minus 1/2, and let's show it has a 0 on the interval 0, 1. So the first thing we need to do is prove that this function is continuous. So I'm going to look at all the data that's shown here. This function is not, here's an e to the an e to the x, that's an exponential growth. It looks like it's shifted to the right a little bit and then it's moved down 1/2. So I need to make sure that it's continuous for all these values. I'm just going to kind of do a little bit of plugging in my head. If I plug in a 0, that's a good output. If I plug in a 1, that's a good output. I know that there are no asymptotes in here because there are no undefined values or denominators that it can't be. If I did graph this in my calculator, I could see that if I looked at this function, it should look something like this. So if you were to graph it in your calculator, you could show that that function is continuous. So the first thing we're going to say is f of x is continuous over the interval 0, 1. Now the next thing we need to prove is if I do plug in those values, so we want a 0. So we're saying it needs to cross the x-axis at some point between 0 and 1. So what we want is between 0, so there's an x equals 0, there's an x equals 1, so that's an x equals 0 here, let's call this an x equals 1, that between that, a 0 exists. So if I plug in, so let's get this done. If I plug in a 0, I should get negative 1/2, right? Because 0 times doesn't matter what 0 is multiplied by. But 0 minus 1/2 is negative 1/2. And if I plug in a 1, that's 1 times, let's do the math up here, 1 times e to the 0 minus 1/2. E to the 0 is 1, so 1 minus 1/2 is just going to be positive 1/2. So I can already see that there has to be, if the function is continuous, and if I plug in a 0, my output is negative 1/2. So going back to my graph here, if I plug in a 0, my output's negative 1/2. If I plug in a 1, my output is positive 1/2. Then I know that if this function is continuous, at some point it's going to have to cross the x-axis and give us an output that gives us a 0. So we need to be able to justify this mathematically, and when we justify things mathematically, we have to be able to prove beyond any kind of speculation. So that means that we are justifying beyond speculation. It needs to kind of say, it needs to answer all the but what ifs. So the first but what if is like, well, but what if there's a jump discontinuity, or what if there's a hole or an asymptote? I answered that already. F of x is continuous. But what if the values aren't below and above 0? I answered that already. F of 0 is negative 1/2. F of 1 is 1/2. So after these three things are answered, let's make a continuity statement here to show that that 0 will exist. I'm going to say if f of 0 is less than 0 and f of 1 is greater than 0, there must be a value c where c is between 0 and 1 and f of c equals 0. So all we're saying here is that we want that output to be 0, and we know that f of 0 is negative 1/2 and f of 1 is positive 1/2. So there must be a value, and I made up the variable c. You can use whatever variable you want, where c is an input that is somewhere between 0 and 1. So going back to my graph, somewhere between 0 and 1, where the output, that f of c, has to be, where that f of c has to be 0. I'm going to paste in also, this is the intermediate value theorem. It is in your shared notebook under those like calculator or calculus cheat sheet. This is how to answer an IVT question. So same thing that we did. We said this is continuous on the interval. The intermediate value theorem guarantees there's a value that are between those such that it equals 0, because that lies between both of those inputs. Guys, take a second, absorb this here, and make sure that you are stating all of these facts in order to prove continuity in your intermediate value theorem.